I should say something about the relation of gravitation to other forces, to other parts of nature, other phenomena in nature, and I'll have more to say of a general quality later. But there is one thing that's particularly interesting, and that is that the inverse square law appears again. It appears in the electrical laws, for instance, that electricity also exerts forces inversely as the square of the distance, this time between charges. And one thinks perhaps inverse square of the distance has some deep significance. Maybe gravity and electricity are different aspects of the same thing. No one has ever succeeded in making gravity and electricity different aspects of the same thing. Today, our theories of physics, the laws of physics, are a multitude of different parts and pieces that don't fit together very well. We don't understand the one exactly in terms of the other. We don't have one structure from which all is deduced. We have several pieces that don't quite fit exactly yet. And that's the reason why in these lectures, instead of having the ability to tell you what the law of physics is, I have to talk about the things that are common to the various laws, because we don't know, we don't understand the connection between them. But what's very strange is that there are certain things that are the same in both. But now let's look again at the law of electricity. The law goes inversely as the square of the distance. But the thing that is remarkable is the tremendous difference in the strength of the electrical and gravitational laws. People who want to make electricity and gravitation out of the same thing will find that electricity is so much more powerful than gravity that it's hard to believe they could both have the same origin. Now, how can I say one thing is more powerful than another? It depends upon how much charge you have and how much mass you have. I'm certainly, you can't talk about how strong gravity is by saying I take a lump of such and such a size, because you chose the size. If we try to get something that nature produces her own pure number that has nothing to do with inches or years or anything to do with our own dimensions, we can do it this way. If we take the fundamental particles, such as an electron, any different ones will give different numbers, but to get an idea of the number, take electrons. 2 electrons, a fundamental particle, that's an object, it's not something I don't have to tell you what units I measure in. It's 2 particles that are fundamental particles. And they repel each other inversely as the square of the distance due to electricity. And they attract each other inversely as the square of the distance due to gravitation. Question: what is the ratio of the gravitational force to the electrical force? And that is illustrated on the next slide. The ratio of the gravitational attraction to the electrical repulsion is given by a number with 42 digits. And goes off here. This is written very carefully out, so that's 42 digits. Now, therein lies a very deep mystery. Where could such a tremendous number come from? That means if you ever had a theory from which both of these things are to come, how could they come in such disproportion? From what equation has a solution which has, for one, 2 kinds of forces, an attraction and a repulsion, with that fantastic ratio? People have looked for such a large ratio in other places. They're looking for a large number. They hope, for example, that there's another large number. And if you want a large number, why not take the diameter of the universe to the diameter of a proton? Amazingly enough, it also is a number with 42 digits. And so an interesting proposal is made that this ratio is the same as the ratio of the size of the universe to the diameter of a proton. But the universe is expanding with time. And that would mean the gravitational constant is changing with time. And although that's a possibility, there's no evidence to indicate that it's in fact true, and there are several difficulties, partial indications that it doesn't, that the gravitational constant has not changed in that way. So this tremendous number remains a mystery.